Hi, welcome to my new unit on the derivative of polynomial functions. And a polynomial function is the p of x equals a x to the n plus b x to the n minus 1 plus c x to the n minus 2 plus etc. 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 So it's a polynomial. And the first video that I'm going to do in this unit is introduce you to the idea of a derivative. In math, a derivative refers to the instantaneous rate of change of a quantity with respect to another quantity. So let's look at a square, and I want to mention that the derivative is the instantaneous rate of change. And if you look up my unit in pre-calculus called average versus instantaneous rate of change, you'll see the idea of the instantaneous rate of change being a slope. So this is referring to a slope. So let's take a square, make it 4 right angles in the corner, and a square has all sides equal. So the area of a square as a function of s is the side being squared, length times width is x times x. So the instantaneous rate of change of a square in relation to the length of the sides at some value of c. So that instantaneous rate of change is the slope. So the slope is, and if you take the ordered pairs like this, if you have x1, the area of x1, and you have x2, and you have an area for x2, then the slope, if you think about the slope formula is y2 minus y1 over x2 minus x1. So if you take this as x1, y1, x2, y2, so the instantaneous rate of change, or the derivative, is the slope. So it's y2 minus y1 all over, sorry, the area x2. So when I say y2 minus y1, x2, which is x2 minus x1, because that's x2, that's x1. So the instantaneous rate of change, which is representing the derivative, is the rate of change of the area as a function of the length of its side. So we also can refer to the derivative, and another name for derivative is, we can also define it. Derivative is defined as the slope of the tangent, to the curve at some value of x. So we're going to concentrate on the derivative as the slope of the tangent to the curve at some value of x. And let's move on to the next page. What I have here is that I have f of x equals x squared, which is a parabola. I've already drawn the parabola, but I'll put 0. If you put 0 in this equation, you get f of x is 0, which is right here. If you put 1 in, you get 1 squared is 1, so 1 gives you 1. If you put 1.5 in and square it, 1.5 is 3 over 2, so it's 9 over 4, or 2 1/4. If you put 2 in the equation, 2 squared is 4. If you put 3 in the equation, 3 squared is 9. So this is, I've only drawn the right side of this parabola. I didn't, also the parabola will loop like this and go this way, but I am only looking at the right side to illustrate the idea of a derivative. I'm not looking at the left side. I could look at both sides, but right now I'm just looking at this side. So what we have is that 1, again, gives us a 1. 1.5 gives us 2.25. 2 gives us a 4. 3 gives us a 9, which is way up here. And what I want to do is that I want to look at the idea of looking at the slope. And let's see, let's take a ruler and look at the slope. In instantaneous rate of change, when I was looking at the slope on the instantaneous rate of change, we were looking at the slope of the secant. So if we want to look at, let's say we want to look at x equals 1, what's the instantaneous rate of change, or the slope at 1? So to do that, what we'll do from 1 up to 3, this is x is 3, 9 to 1, 1, I will draw a secant. So notice we get the slope of this secant where we're going to by doing y2 minus y1 over x2 minus x1, but that's at 3. If you go to 2, 2 gives us a 4, so we draw a secant. A secant is a line that cuts the curve at 2 points. So notice now we draw from this point to this point, 1, 1 to 2, 4, and we have the slope of this secant. And if we take 1.5 and draw the secant like that, so notice that I'm getting, as I go from 3 to 2 to 1.5, this secant is getting closer and closer to the tangent. So the closer and closer I can get to 1, the closer I can get to 1, let's go close to 1, and I'll draw this one. And I'll just do this now to draw this. I'll use my other color pen so you can see it. So I have that as I get closer and closer to 1, I'm getting closer and closer to the tangent. And that's what we did when we referred to in the instantaneous rate of change unit. I did many videos on that to explain it. We get very, very close. So let's say we picked at 1. So we pick a value and the instantaneous rate of change close to 1. So we can pick 1.001, do the slope of those 2 points, passing through those 2 points, and we'll get the instantaneous rate of change because it's very close. So to illustrate that, I also want to look at this graph here. So let's take this point on the graph. Let's call this x, this point, and we'll move over further and we'll take this point. So the distance from here to here, I'm going to call it h. So this point now is x plus h. So this point right here, the x coordinate is x plus h. This is x. Now, that means that this point right here is the y value is, this point is x, and it's the f of x, because that's the x and the y. So that's the x and the y. This is referred to the y as the f of x. So this new point, if you want to take it right here, so this new point has x plus h as the x coordinate, and the y value up here is the f of x plus h. So that's like taking 3 here and calling this a 4 by adding on 1. So this is 3 and whatever the y value is, and this is 4 whatever the y value is. Again, the x coordinate here is h, the y value is the f of x, and the x coordinate here is to add on the h. Really, I don't need those brackets there. Those brackets are not necessary. That's x, and that's x plus h. So there's the x coordinate added on. h added on is the new x coordinate, and the y value of that is the f of x minus h. And the derivative is the slope. So when we think of the slope, we think of the derivative. And even though I'm going to use this, I'll explain in a minute, the derivative of the slope is the derivative, and we're going to use the symbol f with a notch here. So that symbol indicates derivative, and the derivative is going to be the limit as as h approaches 0. Let me go back and explain what I'm trying to. So when I did this, the x value began to decrease. So let's say this is a 3 as a 4. Let's say we're looking at 1. So this 4 is actually 3. Let's go with 1 first. It's 1 plus 3. The 3 is 1 plus 2. The 2 is 1 plus 1. And this was 1.5 here. So this point right here is 1 plus a half. So 4 is 1 plus 3. 3 is 1 plus 2. 2 is 1 plus 1. 1.5 is 1 plus a half. Notice this h that I added on here. This h is being represented. So notice the h is 3, 2. As I move closer and closer to 1, the h value is 3, 2, 1, a half, and it's going closer and closer to the 0. So the h, as h approaches 0, which is, you see, is 3, 2, 1, a half, the closer I get, this value of h that we have on this coordinate is approaching 0. So that means we have the f of x plus h minus the f of x all over. So it's this point right here is x1, y1. This point is x2, y2. So it's the f of x plus h minus the f of x, and x plus h minus x. So again, this is x1, y1, and this one here is x2, y2. So when I do the slope on this notation here that you see with the f of x's, it gives you the derivative is the limit as h approaches 0, the f of x plus h minus the f of x, and the x's cancel out here, and I get it over h. So that's the definition for the derivative, because the derivative is the slope of the tangent. So the derivative, I want to keep repeating that, the derivative is the slope of the tangent to the curve. So if you draw a tangent, if you pick this point, again, if you draw, this is a secant here, but if you have it very, very close to as h approaches 0, so the derivative is the slope of the tangent to the curve at x equals c, some constant number. So it could be the slope of the tangent to the curve where x is 1, where x is right here, or where x is 2. If this was 2, it would be right here. If x was 3, it would be right here. And you've got also, probably got this side over here, we could get the slope of the tangent at -1/2. So the tangent would be coming in like this. So this is the definition. It's as h approaches 0. Okay, let me turn this over now. So I want to mention that symbol that I'm going to use. If you got the f of x, then the derivative is f prime. If g of x is g prime. The p of x, p prime. So this symbol represents the derivative of P, G, and F. Note, it's not f to the negative 1 of x, because that's an inverse. So a negative 1 is an inverse. G to the negative 1 is an inverse. And P to the negative 1 is an inverse. So it's P prime, G prime, F prime is a symbol for inverse. And repeat, the derivative is the slope of the tangent to the curve at some value of x, whatever that value is. So that's the introduction to the idea of a derivative. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.